In this chapter, we're going to talk a lot about the natural base, which is base E. You may have seen that letter before, which represents a number, but we are going to study it quite a bit in this unit, not really particularly in this section, but more when we're solving real-life problems, we will run into E quite a bit. So the natural base E is called the natural base because it occurs a lot in nature. And so we're going to be looking at a lot of science-based applications when we use E. There's also one financial application for E that we're going to study as well later. So E is defined as, it's pretty fancy, the limit as n, going to use an n in here, n approaches infinity of the function 1 plus 1 over n raised to the nth power. And this little function here, 1 plus 1 over n raised to the n, actually does have applications in the financial industry as well. If you evaluate this limit, which is really beyond the scope of our course, if you end up taking calculus, you'll probably look at this a little bit more because you do study limits quite a bit, more than even we do. And you evaluate it, you're going to end up getting about 2.718, etc. The number E is a lot like the number pi. It's an irrational number that continues forever. And so I just think it's nice to know that it's about 2.7. I think it helps us know that E is not a variable. E is actually just a number. And so we shouldn't exactly always treat it like a variable because it doesn't vary. It is that number. Okay, so in this section, we're going to solve some basic exponential equations. And in the future sections, we're going to look in detail of how to solve many different types of exponential and logarithmic equations. But first, the only ones we can solve right now using what we know about exponents are pretty basic here. So take a look at number 1, and that is going to be the basis for how we solve all these problems. Okay, so 2 raised to the x power equals 2 raised to the 8th power. What do you think x is? Doesn't x have to be 8? Right? Because it's 2 to some power is equal to 2 to the 8th. So obviously you can kind of see x and 8 are equivalent. So that's the strategy we're going to use for all these problems. We're going to get the bases equal, and then therefore the exponents will be equal. Okay, so look at number 2. 3 to the x minus 1 is equal to 3 to the 4th power. Okay, so since those bases are both 3, then the exponents have to be the same. So we're going to say, well, then x minus 1 is going to equal 4. Okay? So x is equal to 5. Sorry, I just want to scoot down a little bit. All right. So number 3, you notice that we got a little problem here, right? The bases are actually not equal. So just because 2 to the 2x is equal to 16 to the 3x minus 1, you can't now say that those exponents are equal, right? Because the bases aren't equal. So like that wouldn't really make sense. However, hopefully you recognize that 2 to the 4th is equal to 16. Right? And so it's not by accident that they used 16 here. Like they didn't use 15, okay? If it was 15, we would have to solve this in a different way and we would end up using logs and things that we don't quite know about yet, okay? But since it's 16, we know it's 2 to the 4th power. So what we're going to do is replace the 16 with 2 to the 4th. okay, because they are equal, so we can just replace them. And then we still have this 16 raised to the 3x minus 1. The other side is still 2 to the 2x, okay? So now this is 2 to the 4th raised to the 3x minus 1. The rule for power raised to a power for exponents, that would be like saying a to the 2 raised to the 3rd power, right? So that's a squared times a squared times a squared, because it's 3 times. That is a to the 6th, okay? So the rule is that you multiply exponents. So that's important here because the 4 has to be multiplied by the 3x minus 1. So now look, the bases are the same. They are both 2. So we can say, well then 2x is equal to 4 times 3x minus 1. Okay, so to solve this is just a linear equation now. So that's 2x is equal to, let's distribute that 4, 12x minus 4. Okay, let's combine the x's on the right side and move the 4 over to this side. So in other words, 12x minus 2x gives us 10x. Add the 4 to the other side. And now let's divide both sides by 10 to get the x by itself. So 4/10. Okay, and we could simplify that. X would be equal to 2/5. If you're ever wondering if you did this right, you can definitely just plug in the x. Maybe use a calculator. You don't have to, but maybe do. And check that each side is equal to each other. Okay, let's look at another. 1/4 raised to the x is equal to 8 raised to the 2x minus 1. Okay, so really 1/4 and 8, I mean, they're not common, they're not the same base, but I feel like I would like to change them both to base 2. I hope you do too, because I think that's the base that they really have in common. So in other words, we need to think over here. 1/4 is the same as 2 to what power? Okay, think about that for a second. So 1/4, I mean, obviously it needs to be squared to make the 4, and then you need the negative to flip that fraction, right? That's how you get that reciprocal. So 1/4 is equal to 2 to the negative 2nd power. And then we also have the base 8. So 8 is equal to 2 cubed. Okay. So on the left side, let's replace 1/4 with 2 to the negative 2nd power. And that is still raised to the x power. And on the right, we have 2 to the 3rd power, and that's raised to the 2x plus 1. Okay, so now that the bases are the same, now we will solve the exponents. So set the exponents equal, so that would be negative 2x, and that's going to be equal to, remember, we're going to need to distribute, so 3 times 2x plus 1. Okay, so negative 2x is equal to 6x plus 3. And then let's move the x's over to the right again. So that would be add 2x, so 8x. And let's move the number over to the left, so minus 3. So x is equal to, divide by 8, negative 3/8. Okay. Let's do one more together. I'm running out of room a little bit, but I think I can fit it in there with a different color. So this is the natural base, e, but you know, that probably won't matter as long as both sides are base e, right? So, because then the exponents will be the same, so we'll treat them the same way. So on the left side, we have e raised to the negative x squared. On the right side, we have e raised to the 2x times 1 over e to the 3rd. Okay, So let's rewrite the problem. Okay, so 1 over, and think about this, 1 over e to the third, okay? Isn't that the same as e to the negative third power, right? Because of our reciprocal negative exponents, okay? So if we are actually multiplying, this would be e to the 2x times e to the negative third. Okay, this is introducing or reminding you of another exponent rule. When you multiply two exponents, so multiplying, let's say like if we were doing x to the third power times x to the fifth power, okay, that would be x to the, now this is 3 x's, x times x times x, and then multiplied by another 5 x's. So x times x times x times x times x, right? There's 8 x's total now. So this would be equal to x to the 8th. So you add the exponents. So I'm trying to remind you of some of these little rules over on the side here, because this is how we're really solving the problem. It's a lot of algebra, right? Thrown at you. All right, so this, in other words, since we are multiplying this times this term times this term, we need to add the exponent. So this is e to the 2x minus 3, you know, plus a negative 3. This is e to the negative x squared. Hey, now, I know that problem looked really complex, but look now, the bases are the same, so therefore the exponents will be the same. So negative x squared equals 2x minus 3. Okay, so to solve this, this is a quadratic. So let's add the x squared to the other side. So x squared plus 2x minus 3. And then let's see if we can factor, because I sure don't want to use the quadratic formula after all this work, right? All right, so this is x and x. Let's see, 3, negative 3. So 3 and 1. And then if we add the 3 and we subtract the 1, we get a positive 2 for the middle term when we add. So that's x is equal to 1 or negative 3. Okay, so if you take a look back at the problem, that means we could put 1 in and get this to be equal to each other, or we could put negative 3 in, and that will work for x as well.